3 or is it part 4? I don't remember anymore. Either way, in this part, we are going to be adding quite a bit of elements to the game. First, we are going to add power-ups, and I've made a new icon for that, which is just a circle, because it's a temporary icon. So let's start off by doing what we've been doing in the past, and that is create a new 2D object, and that's going to be a sprite, and then we are going to drive in our power-up icon inside, and let's give it a name power-up, like so. Now, power-ups will be prefabs, so we are going to drag it in here. And there's going to be different types of power-ups that will give our player different benefits. So that's something we'll have to do work on as well. So first thing we're going to do is we will create a collision for it. So let's create a circle collider like this, and we want to set it on trigger, and we want to apply a tag of power-up to our power-ups. Now, there we go, like this. And what's going to happen is our power-ups will have to move same way the bullet does from the enemy. So you'll have to apply some kind of a forward motion towards them, same way we apply from our bullets to shoot. So we will be basically copying that logic and applying it to our power-up. So what we'll essentially do is we can we can slightly change our bullet script to match what we need. So let's have a look at this. So what we're essentially looking for is just this. Well, actually, we want everything apart from this function here. So what we'll do is we are going to create a new class, and let's just call it forward movement, like this. And let's have both the bullet and the forward movement open at the same time, like this. There is our bullet. So what we'll do is for everything so we kind of want bullet to inherit the forward movement, because that's what our generic bullet will do. And we're going to remove most of the code from here, and we're going to place it in our forward movement script instead. So again, these guys can go away to the forward movement. All of this can go to the forward movement, and this can go as well. We're just going to change slightly how everything's called. So rather than call it destroy bullet, we'll just call it destroy object. So this will be replaced here. And let's just change this to the object lifetime instead of bullet, like this. And of course we have some issues now here, but that's fine. We are going to tackle them in a second. So what we will also have is we'll have a onTrigger enter here, but we'll change how this onTrigger enter functions. So where are we? Wait. Do we have to make it public? Yep, there we go. Like this. And because right now we have two sets of onTrigger entries, so what we'll do is we'll change this to to public, and we'll do a virtual. So this is going to be a virtual function. And what's going to happen here is we will do override here. And of course, this has to be public as well. Are we public virtual? Oh, we forgot the void. Like this. Wait. Nope, it's fine. Okay, like this. And what's going to happen here is, so this will be our base function. This will be the overridden one. So this is what we kind of want to do, and this is what happens instead, because we want to keep all of these separate. Of course, later on, if we're going to have separate function for our power up, actually, let's already start splitting power up motions from it. So we'll keep all of this as it is. I don't know if we should change this to actually forward. So let's just change this to a forward vector. I just want to kind of see what will constitute as what. No, so it does have to be up. Okay, never mind. Let's ignore this part. So now that we have this, again, let's just give it a try, because right now we are still using the bullet code if we go into our prefabs, right? But the class is completely changed. But in reality, it's actually all the same. There we go. So now that we have this, we can apply this script to our, well, actually, let's create a new script. And let's call it the power up movement. And then we're starting to get a lot of classes. So now let's make a class that handles things differently. So let's do movements, and in the movements we will have our power up movement, or maybe bullet and power ups. It's a bit more literal, makes more sense. There we go, like this, like this. Let's create a new script, call it utility, and this is where we're going to drag in our utility script. Since we're going to do a save system, let's create a new folder for save system, and then player instance, and that's going to be all of the scripts that are handled within the game. And let's leave the rest as they are. So let's go into the new folder that we just made and go into the power up. And what we want to do is just remove all of the code here and change this to forward movement and just make the overridable function. So public override. And now we see here that this is the only function that we can override. So we will not call the base, we will just call our own, and we will do if collision.transform.tag is equal to player. Then we can just do destroy object. So if our power up collides with the player, it gets destroyed. And this is the class that will be, this is what's going to be attached to our player. So destroys the power up and applies the new power to the player. Handles the power up functionality. I guess power up movement in a sense is not the best name anymore, is it? Well, it's okay. Maybe we'll change it in the future. So now let's check a player. So our player has a rigid body. That means our power up doesn't need to have it. It's alright if it's just set on trigger. And let's just double check that our player has the player tag. So he does have the player tag. Now, of course, the problem now will be that our power up will go up. And it's going really fast. So let's change the speed. But what if we rotated? Wait, is that the wrong axis? Or is that the correct one? That doesn't do anything. 180. So yeah, there you go. That's actually fine. Well, That's still way too fast for our power up. There you go, and we can just pick it up. So that's better. Of course, let's go and make it prefab. Oh, it already is a prefab, so let's do this like this. And now let's make it so our power up actually spawns from our enemy. So this is where we're going to expand the enemy script. So what we essentially have to do now is we have to go into our enemy script and we have to slightly change how it functions. So firstly, we need to store in some kind of a power up. Now we will use one, well, in majority of the cases, we will use singular power up icon for most of our power ups, but they will of course do different effects. So the best way to do it is to assign some kind of a power up to that specific power up that we want. So anyways, first we need to, once we take the damage, we need to decide whenever or not we want to instantiate the power-up. And of course, instantiating power-ups is not the best way to handle it. So rather than instantiating it, we will create a new game object and we're going to call it the power-up pool. And this will be pulling up our power-ups. Actually, something that we need to add to the pooling script is we are going to attach every pulled bullet to this specific game object. And the reason behind doing that is because it gets really messy in a hierarchy. So if we just quickly press play and start clicking, we see that all of those bullets are here on the left, and that just gets a little bit messy in the inspector as we are working on the project. Of course, that will make no difference later. So what we'll do is, when we create our object, what we want to do is we just want to do, before we disable, we just want to do goal.transform.setParent, and we'll just do this. So dot transform. So this object will now be the parent of our bullets and any other power-up that will exist within the project. So let's give this a try now. Now we see that we do have them in here instead, which is way neater than before. So now let's go back here. Let's just close the pooling. We don't need it anymore. So like I said, we want to create a new pooling script. So let's add another instance of the pooling script. And now we want to add is our power up object here. We can reduce the amount of power ups that we spawn at any given time. And later on, we can set so we can only spawn so many power ups on the map at once. But for now, we're just going to leave it as this. So now our enemy has to have a chance of dropping the power up. And aside from chance of dropping the power up, the enemy also has to have what's it called? It has to have a reference to the object pool. So we will do a serializable field. Actually, we don't have to do a serializable field. So let's just do a private, and we'll do power up pool, private pooling. So this is going to be the power up pool. And when we first create the object in our start function, we want to, actually not in a start function, when we will need to, or yeah, and we should technically assume that every enemy that gets spawned will have to die. So it's probably better this way. So what we're going to do here is, in our little power-up script, we are going to look for our power-up. So we'll do this is equal to GameObject.find, and we're going to look for power-up pool. Like this, we have to make sure the naming is right, and then we'll do getComponent pooling, and that then grabs the pooling reference to this specific script. Now, since this is a one-liner, actually, I presume it's going to be more than one lines in the future. So let's just leave it blank right now. So let's comment reference to the pooling script of power-ups, like this. And what we essentially want to do now is, if we take damage, we want to do a roll, so a chance of spawning the power-up. I think the best way to do that is to have some kind of a class later on. that will determine that. But for now, let's just do a integer random chance, and let's make it something like there we go. So we'll have private integer here, probability rate, and let's just set it to something like 33. So we will draw a random number between 0 and 100. So we'll do random.range like so. And then what we'll do is, if our random chance is smaller than or equal to our probability rate, then we can create a power up that will spawn within the game. And we will do this by, again, pulling the object. So we'll do pull power dot get, what is it called? Get pulled object like this. Of course, let's cast this as a game object. So game object, let's call this power up, is equal to this, and then what we have to do is powerup.transform.position is equal to this.transform.position, because we want the power up to spawn from where our enemy's at currently. And we want to make sure that our rotation and position is the same to our enemy. So transform.rotation is equal to this.transform.rotation. Now, something that we probably didn't do right now is we didn't set up the rotation on any of the enemies. So if we click them, we see that the green is facing up, but in reality, the green should be facing, where are we? Down. So what we want to do is change the Z on all of our enemies to 180, or so our little power up spawns directly from below them. Or in fact, we can even modify it that rather than caring about this, our power up will always move downwards. So we can do this by going into our forward movement, and we can just change how this section works. So let's create a new vector. So let's create a private vector2, and this is going to be the fly position, or like the direction. Let's just call it direction. So rather than doing transform up, we will just do the direction instead. And on, where are we? Wait. Can we do that? So transform.opt should be, let's just quickly Google. What is transform.up in Unity? Oh, actually, we can just use the transforms. There is no point to overly complicating. Now that I've looked it up real quick. So going to keep the enemies rotated towards the player always, facing down. But of course, we will just play around with the sprites later on a separate layer, maybe. I don't know. We'll see when we get to it, to be honest. There's no point overcomplicating anything at this stage. Let's go to our enemy now. So we have our pooling, we have the probability rate, and we have the position. So let's do power up the transform the rotation is equal to this dot transform the rotation, and then finally power up dot set active, and then I'm gonna make it equal to true, like this. So let's kill some enemies and see how that's gonna affect the gameplay. Now, there we go. So now we have a chance of spawning the power-ups. Of course, they die way too early right now. They disappear way too early. So that's something that we definitely have to change, but that's not a problem. What we have to do is just make this field serializable as well. And that's something that we will adjust through testing more than anything. So that will probably be something like 20 instead. Let's just make sure the power-up does reach the end. And you probably are very unlucky. Nope, we do have one spawning. And as soon as we... There you go. So whereabout does it disappear? We can definitely trim a lot of time off of what we gave it. So let's just narrow this to something like 13 and leave it at that, because we don't want it to keep going for too long. So now that we have the ability to collect our power-ups, of course, we will not add any ability to change what the power-ups do, because I actually haven't decided what kind of power-ups we want in the game. So I need to put some thinking into that, and that's definitely going to be something we'll tackle next, maybe in the next part. But now let's do the second part of what we wanted to do today, which is prepare for the save system. So this is our current main menu. It just has 4 buttons. I'm thinking we might have some kind of an upgrade system, but I do plan to do some research after today's stream and figure out a proper UI layout. So that's something that we'll definitely do next. So let's create the 2 scripts that we need in our save system. So first, let's create our player. Let's just create a player script. So this will be all of our player data, which will be saved in here. And let's create a new script and call it the save load manager, like this. Now the player script is going to be very small. Let's start with the bigger one first. Now, first thing that we want to do is we want to make this a static class. So that's the first change that we're going to do. And we don't want it to be a mono behavior class. Now, before we work on this specific class, we want to make a class outside of this class. And that's going to be our that will be a public class called player data. Now, this is where we will serialize all of our data. So we'll do system.serializable, so we can actually access stuff from this class. And this will have stuff like public. This will have all of the information for the data that we'll save. I'm not exactly sure how we will save the data yet. I'm pretty sure it's just going to be ints. I don't know if we will use a. We'll probably do something like this: public int all player data, like so. And actually, instead of making it a array, we're just going to make it a double array, or whatever you call these. And then here we'll make a constructor, public player data, and we'll be getting player, like so. So this is where our second class comes in that we've created. And what we'll essentially do is we will type in something like all player data like 0, 1 is equal to player dot I don't know, music volume, something like this later down the line. And if we go back into our save load manager, we will need some functions. So we will need saving and loading, and then we will also need deleting for testing. So save player data, load player, and finally delete the data used for testing only. So let's start off with the first one, which is the saving, and let's do a public static void, and let's call it save player data, and we're going to be passing again player like this. Don't know why it's not. And we'll use a binary formatter. That means we do need to, I believe, use using system.runtime.serialization.formatters.binary. And I think we also need to do using system.io. I don't know if using system on its own will also be required. Either way, we'll delete any unnecessary unused references afterwards. So binary formatter, and that's going to be our binary formatter, and that's going to be equal to new binary formatter like so. Then we will do a file stream, and we will do file stream is equal to new file stream, and we will use application.persistent data path, and we will just do something like player data, and we will use anything at the end. So let's just do something like RV at the end. And the file mode that we want to have for this is create. So file mode dot create, because we are creating the file. Now next we will have our player data, and we'll call this data, and we'll equal to new player data, and we'll be passing through the player. And finally, once we've opened and saved the things, we need to serialize now. So we'll do binary formatter.serialize, and we'll be passing the file stream as well as the data. And now that we are done passing everything through, we can just close our file stream like this. Now, this is all we need to save all of our data, given that we do have the data in the first place. Now let's create the loading function. So the load function is very important on the type that we use to save down here. So we will do this by doing public static, and we'll be using int as a return type, and we'll be doing this because this is how we're at least planning to save it right now. So load data, actually, how did we call it? Save player data, load player data, like this. We don't need to pass anything because all we do is just retrieve the information that's already stored. So first thing we have to do is make an if statement which checks if our file exists. So if file exists, and we'll of course copy our path from here like this. And the file mode now is going to be, if you can imagine, open, because we're opening instead of closing. It's actually here. File mode dot open. There we go, like so. Actually, no. What am I doing? We're not opening, we're just checking. There we go. Okay. And then else, just a precaution. So this is where we return null, not to have the return problem. I am missing it. Go away. And we can just do some kind of a debug.log warning, and something like actually log error could do. And what we're going to type in here is file does not exist. So we technically should never allow our project to do this, because we should first check if, so we'll be checking if the file exists. If it doesn't, kind of have to create a new empty file. How did this add itself? Anyways, now that we have that, let's just do basically the same thing as we did down here to an extent. So I'm just going to copy them and change what has to be changed. So of course we are not creating, we are opening. We still have binary formatters, so that's fine. File stream, it's all good. We are going to have a data, but this is going to be now not a new reference, because we are not. What we instead do, we use the binary formatter to deserialize the data instead. So as we see above, we serialized it, but here we are deserialized it, and we pass through the file stream, which is from the string location that we've gained, and we do this as player data, like so. So this saves it in this order in here, and this reads it. Excuse me. Oh. And once that is done, we use file stream dot close to finish it off, and then what we return is our data dot all player data. There you go. Actually, I need to do it like this. So now we return the integer as we wanted to. So with this, we've set up all of the save and load, and now we just have to create things that we need in player. So player will have to store the local changes here, and then we will have two public functions. First one is going to be public void save, and the other one's going to be public void, as you can imagine, load. We might have individual smaller one which save only a specific set of data rather than saving everything every single time. So we could only, for example, just save just sound or just save thing, but at some point we'll always have to save everything anyway. Anyways, so what our save will do is will of course save all of save all of the data, and then once we're done saving, we do save load manager dot save player data, and we do this because this is the class we want to save. We will keep mono behavior on this because this is something that needs to be kept. This will be attached to an object that will be carried through all the scenes from the moment we instantiate the project as well. Maybe we'll even make this. That object we will see later. Anyway, and for the loading is basically the reverse of saving. So what we'll do is we'll create a variable like this, and then we're just gonna call it something like loaded data, and then we'll do, actually, we can do this step, save load manager dot load like this. So this is what loading will do, and then we have to assign each element to what it should be. So assign all the data correctly. So that would be something like loaded data 0, 1 is equal to, I don't know, volume, something like this. So that would be essentially the opposite what the other one would do. And here in the saving one, we'll do something like, well, wherever we'll make sure that the values that are stored here as the public variables, so like volume would be saved to volume as well, etc. But yeah, with this done, we actually progressed significantly throughout this project. I believe we'll be doing some UR work and maybe some. Well, I'll need to have some look at some references to be able to figure out what I want to do with this project. But we'll definitely work on. What are we? We're going to change the UIs so it looks closer to what a mobile game would look like. We definitely want to implement some kind of a wave systems, boss systems. We want to expand on our current mechanics. So that's something to look forward to in the future. But this is it for today's stream. Thanks for watching.